which for primitive types is basically what it does anyway. So, because that's how primitive types work in C. But for object types, if you just have a sign, it will just it'll just assign the pointer. It won't actually make a copy of the object. Okay, and then one last little bit that you can flip is the atomicity of the write. So by default, accessors are atomic, which means that only one thread can access it at any given time. If you know that your code is not going to be written in multiple threads, and that only one thread could ever possibly access the variable at one time, you can specify that it's not atomic, which says, okay, multiple threads can read and write at the same time, which if you have a multi-threaded program is dangerous, of course. But the reason you might want to do this is that it's more efficient because the system doesn't need to write locks and semaphores and all this mutexes and all that garbage to make sure that only one thread can read it at a time. So if you only have one thread, you might as well make it more efficient. Okay, so here's some examples. So we have our fraction class again. We have numerator and denominator. We probably just want since again, I'm going to assume we're in a single-threaded program, so I'm going to mark these as being non-atomic, meaning make them fast, basically. And I'm going to say assign, because memory management doesn't quite make sense for integer types, because they're just integer types. So C, I'll just say to assign them. I don't actually need to say assign, again, because that's the default, but sometimes it's more clear to people if you actually specify what property you want to set. So maybe I have it. So here's another example. We have a checkers board, and maybe I have some array that I keep the board in. And at some point, maybe I want to be able to change the board and reassign the board. So, oh, that's kind of a silly thing. It's read only but retain. So I don't know why I did that. So you can specify it to be read only, meaning that you can't write it, but you can read it. And for some reason, I thought, well, if you do happen to assign it, you can retain it. But that doesn't quite make sense since it won't write a setter for you. Oops. But, I mean, suppose if we wanted to be able to change the board, then if I made this read write and retain, then it will retain the object every time it's assigned. And again, we'll talk about what retain means later. Okay, so again, here I'm showing an example of I didn't declare an instance variable of type string named name, but I can still create a property for it, and in the newer runtime, it will generate the correct instance variable for you. So here I've made a property for name, and I've just set to copy it every time you assign to it. So that means it won't destroy. It's kind of unnecessary for in a string because it's immutable anyway. But again, just to kind of show kind of all the bits you can flip. So here's kind of another example of using the setter and getter changers. So suppose we have a light bulb class, and we want to have a Boolean flag of whether or not it's turned on. And I'm going to call it lit, but maybe it doesn't quite make sense to have the getter be lit and the setter be set lit, because that sounds kind of weird. So again, I'm sticking with convention and having the getter be is lit, and the setter, it makes more sense to say set light, I guess, to say whether the light's on or off. So this will generate the methods is lit and set light. And if you just use the dot syntax, you really don't need to worry about that, because under the hood it'll create these for you. But the cool thing about it is when you declare a property, you can actually call it as a method and not use the dot syntax. So you can go back and forth, and it'll just write these methods for you. Okay, so before I move on, do we have any questions about properties? Yeah.
Why don't you just call it is lit, and then you can just set the setter but not the getter? Does that make sense? Like if you called after bool you wrote is lit, then you wouldn't need to change the setter. You wouldn't need to change the getter, only the setter. Is that like?
Yeah, that's kind of a style question. Generally, Apple will discourage you from using words like is or my or our at the beginning of variable names, just because they think it's kind of redundant and silly looking. And it's a style choice. It's just kind of convention. Any other questions about properties? Yeah.
Is there any need to write the instance variables in the other braces?
Not since I believe Snow Leopard.
Yeah, if you want to run on older systems, pre-10.6 systems, you do have to declare an actual instance variable. I found this out the hard way.
Yeah.
If you compile a if you compile a project to run universally on older systems, which Xcode will, by default, when you're
building for release, it will compile on all systems instead of just the system you're currently working on.
So when you're compiling for debug, it's usually just the system you're working on because it's faster to build, right? Which, if you're past Snow Leopard, then you don't need to do that. And then suddenly when you switch to release, you may start getting a whole bunch of error messages, cryptic error messages, and that's because it builds 10.4, 10.5, 10.6, 10.7 executables that are all bundled together and run correctly on the correct system. And you'll get errors every time it tries to build the 10.4 and 10.5 versions. So I would recommend declaring them every time.
Yeah, and arguably this is harder to read because the variable type and the name are way the heck off to the right potentially, but if they're just declared within the curly braces, you see immediately right where all of your variables are. You don't have to like combine the ones up there and the ones down here. It's very clear where all of them are. So from that standpoint, I think it makes more sense to put them all in there. Yeah.
If you don't use properties but you declare all your variables, can you still use the dot access?
No.
No.
You can actually, technically, you can coerce the system to use dot to access your methods. Don't do that. Nobody's going to know what you're talking about. But yeah, that's unique to things that are properties. And so you can't use dot syntax for general for general methods. It's only for setters and getters. Okay, so one more topic today is protocols, which is the Objective-C equivalent of a Java interface. It's, again, like a Java interface, it's just a list of methods that does not have implementations that correspond with them. They're shared among classes in the sense that any class can import a protocol. And again, it's the same idea as an interface in Java. So the syntax of a formal protocol is really straightforward. You have @protocol, the name of your protocol, then a bunch of method declarations, and then @end. And again, no bodies for these methods, just the declarations for them. You can also specify whether the methods you want are optional or required. And the way to kind of read these is you just kind of read from top to bottom. So the default is everything's required. But if I want these two to be optional, I can just say @optional and everything below @optional will be optional until I hit an @required, in which case everything is required. And the point of required and optional is when you write a class that implements a protocol, the compiler will be able to tell you if you haven't implemented all the methods that are required. So because hopefully the required methods are the ones that you're going to actually use and call, so you want to make sure that they're actually defined. Yeah. What's your name?
Why is it not here and then protocol?
That's probably a typo, actually. Come to think of it, that should be @protocol. Good. Thank you. Any other questions? Yeah, this would not work as an interface declaration. Well, actually, it probably would. It's just I haven't defined a super class. Well, I don't know what @optional and @required mean in an interface. It might work. Okay, so here's an example. Suppose we've defined a protocol called drawing, and we're writing some drawing app, and we want to define what kind of things a thing that needs to be drawn needs to be able to do. So you can paint it, you can draw it on the canvas. It can be erased, removed from the screen, and maybe it has an outline. So maybe we have this protocol in the file called drawing.h. We have a rectangle class and then the syntax for saying I implement this protocol is after the parent type in angle brackets, you put the name of the protocol that you want to implement. And then you don't need to declare those methods in the header. They know where they come from because they come from the protocol declaration. You just provide bodies for them in the implementation file. Does that make sense? Yeah. Yes, I will get to that in just a second. Okay, so at compile time, you can create a protocol object, and unlike selectors, these actually are objects. These are actual Objective-C objects. You can use the @protocol directive, and it takes in well, I won't say it takes in, it just takes what you put inside parentheses is the name of the protocol, and it will generate a protocol object which you can then pass around. And we'll see why that's useful. So maybe we've defined some XML support protocol that helps us with parsing XML or something. We can create a reference to that protocol class by using the protocol declaration. So we can test objects for conformance to protocol using the method conforms to protocol. So in Objective-C jargon, we say that a class that implements all of the required methods of a protocol conform to or adopt the protocol. So we can ask, again, this is some arbitrary object, I don't know what it is, but if it conforms to the drawing protocol, then I know I can safely call all of the drawing methods on it, because it conforms to the protocol. Those methods have been defined, therefore I can paint it, I can erase it, but I don't know, in this case, that I can, what was the optional one that I wrote? I don't know that I can outline it, because that's an optional method. Does that make sense?
And you'll see this in user interface code too. To check, you may get just an object that's been interacted with, and you may want to check: is it a button that actually takes a state up and down? Is it a slider that gives you a value? So that's one example of where this conforms to protocol can be really useful.
Okay. So, as was asked, classes can implement multiple protocols, and the way you indicate that is you just comma separate them within the angle brackets. So, pretty easy. Yeah?
I think you might have just said this. If you're doing this protocol thing, do you have to declare all of the methods in your implementation files, or is there some out?
I mean, you're perfectly at liberty to leave some out. The compiler will generate a warning for you if you do not fulfill all of the required methods.
And if they get called, it'll throw an exception.
Because the method isn't there. Good question, though. Okay, shall we move on? So, type declarations can be attributed, can be extended to include protocols. So this can verify that the objects in this type, if you want to immediately know that they conform to a protocol, you can tag on to the end of a type declaration the protocol you're interested in, and then the compiler will actually warn you if you're assigning to an object that does not conform to that protocol, so that you can make sure that this object actually does conform to that protocol at all times. And again, you can do this with id, but you can also do this with a static type. Unfortunately, with the star ends up in kind of a weird spot with pointer types, but you just have to deal with it. If you're of the school of keeping the star on the right, it doesn't matter. It's the same. It looks the same anyway. Glenn might put it on right next to the angle bracket, and then it would look a little bit funky to me. Okay, so that's all I have to say about protocols. It's fairly uncommon for you to have to write them, but it's very common for you to implement protocols, and hopefully in a couple of weeks we'll see some examples of implementing protocols. So one other topic I have today is categories, which give us two sort of uses. One is an informal protocol, which is basically how they made protocols before they actually had language support for protocols, which are fairly rarely used now, but you can if you want. They're also used for class extension. So here's an example of defining a category. So suppose I have some class that I want to just add some behavior to it, but maybe subclassing doesn't make a lot of sense because it's really just one method I want to add to a class. A great